Hi, and welcome to C Programming for Arduino, a step-by-step guide. In previous video, I mentioned that we will write a function which determines whether a user entered year is a leap year or not. Before writing the code, we will discuss some considerations in order to make our function. First, we need to decide what data type do we need the function to return. Although the leap year function for most language libraries return a boolean value, that is true or false. But we want our program to return an integer value. Why an integer data type for the return value rather than a boolean? The reason is because the most common use for a leap year calculation is to determine how many days there are in February for a given year. Perhaps that day makes a difference in billing cycle, interest payment, or some other calculation. Consider these two codes. Both of these codes determine the days in February based on the output from is leap year function. But first function returns a boolean value. As boolean value cannot be used in calculation, thus we have to use an if statement to determine days in February. In second code, integer value is returned which can be used in calculation, and we do not need an if statement. You can see that second code is much smaller than the first one. This is the reason we want our function to return an integer value. Name of our function is leap year. This name suggests that the function is going to address the task of finding out whether a given year is a leap year. Our function does need data from outside world to accomplish its task. Specifically, the backpack needs to have an integer data type that specifies the year stuck into it before we call the function. Again, visualizing a function as a black box with a single entry and exit point is a good mental picture for the way a function should work. That is, after you write this function, handing the function to another programmer for use of your function should prompt only three questions from them. What task does this function perform? What data do I need to send to the function? And what data do I get back? Here, the function name answers the first question, the argument list answers the second question, and the function type specifier answers the third question. When the day is done, a programmer could care less how you write the code inside the function as long as it accomplishes the task at hand with reasonable efficiency. Also note that the function argument list corresponds to the input step of the 5 program steps which we learned in the start of this course. The function body reflects the process step in previously discussed 5 program steps. It must contain the statements necessary to solve the task at hand. Our task is to write an algorithm that tells you to determine whether user entered year is a leap year or not. A leap year algorithm states that if the year can be evenly divided by 4 but not by 100, it is a leap year. The exception occurs if the year is evenly divided by 400. It is a leap year. We can write this code using nested if statements, but we will use logical operators for this purpose. So let's discuss logical operators first. Logical operators allow you to combine logical expressions. Following table presents the logical operators and examples. Note that x and y are two logical expressions. The AND operator is formed by placing two AND characters back to back with no space between them. Consider the following truth table of AND operator. For example, suppose you have variables k and j and k equals 2 and j equals 3. Then this statement will be true as both expressions are true. But this statement gives false as k is not equal to 9. A logical AND operation only yields a logic true result when both expressions are true. All other combinations are logic false. The logical OR operator is formed by placing two vertical OR characters back to back with no space between them. This is the truth table for OR operation. Once again, suppose you have variables k and j and k equals 2 and j equals 3. Then the following expression is true. Now, this statement is also true despite k is equal to 9 because the logic OR is only false when both expressions are false. The logical NOT operator is the exclamation point. This is the truth table. This table shows that NOT operator inverts the logic of the expression. For example, not operation of this statement is false as expression k is equal to 2 is true, but operation not has inverted the output. That's all for this video. Thanks for watching. Take care and goodbye.